All right, tension vertical acceleration. So a 35 kilogram block. Okay, so mass equals 35 kilograms. How do I know? Because it says kilogram. Kilogram is mass. What is its mass? All right, they tell it to me, right? One of these is always going to be easy, right? The tricky thing is identifying which one they give me and which one they don't. So they gave me kilograms, and that means it's mass. So its weight, well, okay, well, W equals mass times gravity. And gravity's 10. So 35 times 10 is equal to 350. And what are the units for weight? It's a force, so it's newtons. What is a normal force acting on it? Oh, well, so here it says it's resting on the ground. Well, it's resting on the ground. Well, then it's not moving up or down. So if there's 350 going down, there needs to be 350 going up. And we call that the normal force. All right. Okay. A 35 block rests on the ground. A rope pulls up with 50 newtons. What is a tension force? Well, tension refers to a spring or a rope. And so we're going to call it 50 newtons. They tell it to me right here. The rope pulls with 50 newtons. I know that tension means rope. What is a normal force acting on it? Well, again, it's resting on the ground, which means that the forces are balanced. It still has a weight of 350 newtons. If it's still resting on the ground, the weight is counterbalanced by, meaning the weight is equaled out by the upward forces. So the upward forces, there's two of them. It's the tension now and the ground, right? There's a ground pushing up and the rope is pulling up. So in your mind, you could think, okay, 350 down is equal to two things. You could say the ground is pulling up plus the rope is pulling up. It's a little smaller to fit. Okay, well, we don't know the ground, and we just knew that the rope was 50, and we know that this equals 350. And so this is a pretty simple equation now. What is the question mark? Well, it must be that the ground is equal to 300. So I'm going to say that the normal force is 300 newtons. Final answer. All right. The 35 kilogram block rests on the ground, so it's still resting on the ground. Same scenario. A rope pulls up with 300 newtons. And so again, rope is tension, so that is 300 newtons. What is the normal force acting on it? So again, this is still true, except now the rope is much larger, but it still adds up to 350. So what's remaining at compared to its weight? Well, there's a remaining 50 newtons that the ground is supporting. A 35 kilogram block rests on the ground. How much tension must a rope exert upward to accelerate the box off the ground? So if we're accelerating, all of a sudden we're not in equilibrium. Remember, equilibrium has no acceleration. So equilibrium would mean that it is totally balanced up and down. So far, these were in equilibrium, right? Because it was not moving, it was resting on the ground. So now we need to break equilibrium. We need to beat it. Well, it has a weight of 350 newtons. And right now the ground is supporting it. But I want to pull up with enough force to beat it. So if I'm going to match it, I would say that rope or tension needs to equal 350. But that doesn't accelerate it, does it? That just means that the rope is picking up the slack from the ground. The ground has nothing. So I'm going to say, and one. I now beat it. The rope is beating the weight, and now it's moving upward. Okay. Now the same 35 kilogram box, I guess, has been lifted off the ground by a rope. How much? And so right now, if the weight equals 350, we did that in an earlier one. How much tension must the rope exert upward to keep it going at constant velocity? Ooh, constant velocity. What's triggering your brain? Equilibrium. Better be equilibrium. Well, then the tension needs to be equal to the weight. And so now, again, so what made this one different was we have already gotten off the ground. We're already moving. So what does it take to keep moving? Well, it takes equilibrium. And now they are in equilibrium because they matched. Okay. An 88 kilogram worker stands on a bathroom scale in a motionless elevator. When the elevator begins to accelerate upward, I don't care what that is really. When it begins to accelerate upward, does the worker feel what? Well, this is one where you probably, you probably have some life experience of this. I want you to close your eyes and think about the last time you were in an elevator. As it goes up, do you feel pressure on your feet, or do you feel like you're all of a sudden lighter? You should feel heavier. And if you didn't know that right away, let me explain. If you were in a box, and you felt your gravity's acting on you, so you're going down with a certain weight, and you're not actually moving, so the elevator is pushing back up on you with just a normal force. Okay, so you feel regular. You feel like you're walking down the street, no big deal. But all of a sudden, if the elevator also pushes up, now I need you to think about this elevator is pushing on your feet. It's pushing you upward. So it's kind of like your body's pushing downward. That's so heavy. It feels heavier. And that's the idea there.